screen, it is MKGFLB. So all the people who are in the session, please go to joinpd.com and use the code MKGFLB. So we'll wait for a minute, let other people also join, then we'll start. Okay, so 12 students have joined here. So all those people who haven't joined it, please go to joinpd.com and the code you can see on the top right side corner. It is MKGFLB. We'll start with the first problem. It says the CDF of a random variable x is given and you have to find probability x less than equal to 10.
हाँ बा हरा सना दे है आधा मिला है
I have already received 16 of the responses. So let's see. So as I can see that either the people have answered B or A. What is the correct answer of this question?
B.
Anyone?
It is B.
It is
B,
B.
ma'am, B.
Okay. Okay. So how do we solve this? You have the CDF given. So from the CDF, can you recognize what random variable it is?
Exponential.
Exponential.
Exponential random variable, right? So what is the lambda there?
7.
7 is the lambda, right? So we have to find probability x less than equal to 10. So basically we have to find CDF of x at 10. Right? So CDF is already given to us. So we just have to put in place of x, you have to put 10. So what we will get? Somebody had posted in the chat that it is 1 minus 1 minus e to the power minus 70. Okay, Arun Rajan. So the CDF was given to us, right? If you look at the question, it says the CDF of a random variable is given, that is fx of x is 1 minus e to the power minus 7x. Okay. And you have to find probability x less than equal to 10. And we know that the CDF is to find us fx of x is probability x less than equal to small x. So in case of this example, small x here is just 10. So CDF is already given to you. Just have to substitute 10 in place of x. Yeah. Is it okay? Why B is the correct answer? Is it clear?
Yeah, ma'am. Clear.
Yes, ma'am. Okay.
I have a doubt here.
Yeah, please.
Ma'am, should we integrate this one or no, ma'am?
Integration not required, no? I mean, you can also integrate if you want, but okay, you want to integrate the function to find probability.
Yes,
But
ma'am.
what do you integrate? You integrate the PDF, not CDF.
Okay, okay, okay.
You integrate the PDF, you get CDF.
Okay.
So you'll have to differentiate CDF first to get the PDF, and then you can integrate.
Okay, okay, okay. Fine, ma'am. Thank you, ma'am.
Okay.
Thank you, ma'am.
Okay. The CDF is same what we had for the previous problem. Now, in this case, you have to find what is the value of probability that x lies between minus 2 to 4. The CDF is same as what we had previously. we already have some 21 responses. So I would request others also to please join in the session and answer it there. Because I can see some 54 participants are there in the session, but only 28 have joined in to their tech.
Just want I have a doubt in graded assignment.
You have a doubt in graded assignment.
Just one, just one question.
Yeah, okay. So we cannot discuss graded assignment here. So these problems are very similar to what is in the graded assignment. So is your problem, like whatever doubt is there, have we discussed that topic?
I just thought I would make it up.
Okay, we'll take it at the end. Just,
Okay.
the topic we can discuss.
So, thank you.
Yeah, so PDAC. Okay. Again, most of the people here have answered B. See, so how did you find this value? Probability that x lies between -2 to 4. What
F
is
of
it?
4 minus F of minus 1.
F of 4 minus F of -2.
Sorry, minus 2, yeah.
So what is F of 4?
minus
F of 4 is 1 minus e raised to minus 28.
Yes, and what is F of
And,
-2?
1 minus e raised to 14.
Yes, ma'am.
So 1
ma'am,
will get cancelled and ultimately it will be e raised to 14 minus e raised to minus 28.
We will
Okay,
integrate
others? Yeah.
integrate 7 e ka power minus 7x from -2 to 4.
ma'am,
Okay, yeah.
if
Ma'am,
we
can you
cannot
please show
find
us
the probability of
the
minus
function,
value,
please?
Sneha, wait. Sneha, can you repeat?
we cannot find the probability of minus value since it's an exponential distribution starts from 0 to infinity. So we will be taking the probability from 0 to 4.
We're taking the
That's
probability from 0 to 4. Yes, that is right. So what should be the answer?
I wrote A, ma'am.
A. Yes, A is the correct answer. Yeah, who else was there? Somebody was saying
Yeah, ma'am, could you please show us the
Yeah, exactly. How
CDF?
CDF. Okay,
how
yeah.
to work.
So this is the CDF of a exponential distribution where the parameter lambda is 7. So for x greater than equal to 0, your CDF is defined as 1 minus e to the power minus 7x. Otherwise, it takes the value 0.
Oh, yeah, right. We should not
Right?
consider the condition
Yes,
between
so
minus 2
fx
and
of
0.
-2 will be 0. So
Yes.
most of the people here have answered B. So that is wrong. The correct answer is A. Right? So same thing, fx of 4 minus fx of -2. So fx of -2 is 0. So we'll just consider fx of 4 and that is 1 minus e to the power minus 28. And somebody was talking about integration. So
Yes, ma'am.
we'll have to, yeah. So
I find out the PDF in the previous one. So I
yeah,
integrated
yeah.
from -2 to 4. So -2 to 0 less than 0
0, it will be 0.
0. Yes, ma'am. And from
And 0 to
0
4,
to, yeah, 0 to
it will
4
be
is
lambda e to the power minus lambda x.
yes, ma'am.
So you got what answer? A, right?
A, yeah.
Okay, yeah, that is right.
Yes.
Okay. Right. So in this case, you have a random variable that is continuous and the PDF is given to you. So the PDF is defined here and you have to find the value of k. You have to find such value of k so that it becomes a valid PDF. You will have to use the integration formula that is given here. So if you don't know the formula, you can use this.
Hello, ma'am.
Yes.
It's Aditya, ma'am. Hello.
Yes. Yes, please tell.
Ma'am, can you take some integration question at the last?
Sorry.
Actually, yeah. Actually, some can you solve, like help us in the integration question at the last of this session, because I was not able to
Okay.
solve.
Yeah. All right. So I will do some integration part then.
Okay. Thank you.
Okay. So, what is the answer here? Some people have answered it 0. Many of you have answered it 0. So by 13, okay. 0.230. All right. So we know that for any PDF to be a valid PDF, there are 2-3 properties that it has to satisfy. First thing is the function should be greater than 0, fx of x should be greater than 0. And the other thing is, so you can clearly see that in this case it is greater than 0. And if you integrate it over the range, so here it is from 0 to 1. If you integrate it from 0 to 1, it should be equal to 1, right? So once you integrate it, you will get k as 3 upon 13. So the people who are not who are not very sure how to do integration, they'll do it at the end. Okay. All right. So using the same PDF, you have to find the value of probability that x lies between 0 to 1 by 2. So I will go back to the PDF. You can just have a look at it.
Ma'am, can you please show the question, ma'am?
Yeah. Please write your answer in your deck. Do not write it in the chat box.
Please move toward the solution.
Yes.
Yeah.
So what is the answer that you got?
So
0.49.
0.47, I think.
0. Point.
0.47.
Yes, ma'am.
Somebody has written a mole. You have written the probability to be 2.08. So the probability can never be greater than 1.
Greater than 1, yeah.
Yeah. So please take care of that.
0.4711. Yes, ma'am.
Yeah,
14711.
0.47 is the
So we
right
just have
answer.
to integrate.
Yes, ma'am.
It will come out to 49 by 104. You can solve it and get the answer. So we don't have to do anything. It's just you have to find the probability that lies between 0 to half. And we know the PDF here. So if you
Yes.
integrate your PDF over this range, you will get the probability.
Yeah.
Yeah. So I hope all this thing is clear.
Yes, ma'am.
Yeah. Okay. So again, here you have a continuous random variable with PDF 3x square for x lying between 0 to 1. And you have to find the value of what is the probability that x less than equal to 1 by 2, given that x is greater than 1 by 4. Okay,
Yes, ma'am. Please move.
let's see. All right. So how did you find this?
First of all, by we based conditional probability.
Yes, right.
Probability of x between 1 by 4 and
Greater
1
than
by
1 by
2.
4.
Yeah, greater than 1 by 4 and less than 1 by 2 divided by 1 minus probability of x less than equal to 1 by 4.
Okay.
Yes, ma'am. I
All
got 0.11.
Okay. Let's see the solution.
1 by 9 thing.
Yeah. So we have to use the conditional probability formula. So it is given that your x is greater than 1 by 4 and you have to find the probability that x is less than equal to 1 by 2, right? So if it is given that x is greater than 1 by 4, then what is the probability that x is less than 1 by 2? So in the numerator part, if you see, it should be the intersection. So it will come from 1 by 4. The lower limit will start from 1 by 4 and the upper limit will be 1 by 2. And in the denominator part, since you have to divide by probability x greater than 1 by 4. So if you do it, it will be like whatever fx of x is, that is 3x squared dx. And you have to take the limit of integration from 1 by 4 to the range. So the range here stops at 1. So for 0 to 1, your PDF is defined as 3x squared. So we will take 1 by 4 to 1, the limit in the denominator.
Excuse me, ma'am.
Yeah.
Ma'am, here you have taken 1 by 4 to 1 because the range is still 1. But is the 1 included in the range? I mean,
This is a continuous random variable we're talking about.
okay.
Yes, ma'am.
Yeah. So only in the case of discrete it matters, but if it is continuous, the probabilities are same, whatever it comes out to be. So once you integrate it, you will get the final answer to be 1 by 8 minus 1 upon 64 divided by 1 minus 1 upon 64, and it comes out to be 7 upon 63.
1 by 9.
So 1 by 9, that is 0.11.
Yes.
Then we could have also taken 1 minus probability less than 1 by 4, right? Less than equal
Yes,
to 1 by 4.
less than equal to 1 by 4. So, but why do we want to do it? I mean, if fx was given the CDF, then it would have been easier. But anyways, we'll have to integrate. We can integrate this.
Okay, correct.
Yeah.
If I do by that method, then my limit will be 0 to 1 by 4, right?
Yeah.
0 to 1 by 4.
Yes.
Right.
Okay.
Yeah.
Ma'am, one small question.
Yeah.
Actually, ma'am, that things what is given, no, x to the power n dx, that formula, and the integration limit, lower limit is a and b.
Okay.
So also given condition is that x should be greater than 1 by 4 and it should be less than equal to 1 by 2, right? So here what I have taken, like the lower limit a I have taken as 1 by 4 and the higher limit b as I have taken 1 by 2. And I integrated using the formula x to the power n dx, that 1 by n plus 1. That formula also I calculated, I got the same answer 0.11. But is this approach is incorrect, or because I did not follow the which one you are showing here? I did not follow this, but I used that method. The
Here also the integration formula is same, no? So
what I did, like 1 by n plus 1, that is 1 by 3. I just 3x square was given out, so 3 I took it out. And
yeah. So x square will become x cube by 3.
Yes, and
this 3 and 3 will get cancelled out.
Yes, and I got the same answer, but this approach is correct or not?
This is also same, no? Nothing different we are doing here.
Okay, that what I
just
multiplied by 3 into 1 by 3, and that 1 by 2 to the power cube minus 1 by 4 to the power cube, and I got the same answer.
Even here we have done the same thing. 1 by 2 to the power cube, that is 1 by 8, minus 1 by 4 to the power cube, that is 1 upon 64. And in the denominator, it is 1 cube minus 1 by 4, 64. Same thing we have done.
Ma'am,
Okay. No problem.
Yes.
Can you say anything about the nature of distribution, whether this PDF belongs to, I mean, normal distribution or any other sort of distribution? Can we say anything?
Do you think it belongs to any of the distribution you have studied so far? Like, can you figure it out?
No, uniform and exponentials, surely not, right?
Huh?
And I don't think that it belongs to normal distribution also.
Yeah, so it's nothing similar to uniform, exponential, or normal. No? So this is like whatever functions we have studied, like continuous, exponential, normal, it doesn't fall into any of the category. It is just one continuous function that is defined as 3x square. So if you plot it, it will become a parabola, right?
My denominator has only 1 by n plus 1 here.
Sorry, your
My
denominator?
has 1 1 by n plus 1. I do have 2 plus 1, that is 1 by 3.
Denominator is 1 by n plus 1 only.
Yeah, so this is what I call like 1 by 3, that then 3 I have taken it out already, and 1 by 3 multiplied by 0.125, that is 0.5 to the power
Yeah,
cube minus 1 by 2 to the power
same
cube.
thing,
That is
same thing. So here also
but
3x square dx. So x square integration is x cube by 3.
yes.
So 3x cube by 3 we have written. 3 and 3 is getting cancelled out. So in the numerator, we have x cube and the lower limit is 1 by 4, upper limit is 1 by 2. So if you solve
Yes.
it, you will get 1 by 2 to the power cube minus 1 by 4 to the power cube. Here also it's the same thing. Where do you think it is different? Can you?
No, ma'am, actually that 1 minus 9 by 60 was something I did not see that, because I got a simple that 1 by 3 and I got calculated this way, so I thought something is different here. 1 minus 1 by 64, that denominator part is minus, so I just cut it is
Okay, it's fine.
Okay, but I followed that hint equation which is given. No? According to that only, I just put my values and I got the
Yeah,
correct
that is
answer.
the
So that
integration.
approach is also correct, right? Whatever.
What is done
Thank you,
here
ma'am.
and whatever is written there, same formula. That is the integration formula. There is no other formula for integration.
Okay.
Hello, ma'am, I have a question regarding the last one.
Okay, sorry, can you repeat?
Yes, I have a question regarding the last problem.
Maths 1.
Hello. No, last part, the last one.
I cannot hear you properly.
Yeah. Am I audible now? Hello.
A lot of noise. I think you're outside.
Yeah, actually, I'm traveling.
Can you put it on the chat? Can you put it on the chat box?
I'll do that.
Yeah. Put it on the chat box. So here we have a random variable for which the CDF is given to you. It's very simple problem, and you have to find what is the probability that x is going to be 0 and what is the probability that x is going to be 2.
Ma'am, how is this a valid CDF?
0 it will be, right?
Sorry?
0.
How is this a
Which one?
valid CDF?
Sorry, can you repeat?
How is this a valid CDF?
How is this a valid CDF? Why?
It should always be increasing, but in this case, it is decreasing.
Okay, yes, right. Sorry.
Yes, it is decreasing.
Yeah, that's
Not a valid
okay.
CDF.
Yeah. Thanks for pointing out. Okay, so just make it 1 by 4 for the first
Replace
one
it.
and
1 by 4
by
and 1 by 2.
replace
Yeah.
1 by 2 and 1 by 4.
So answer will be
Zero and zero.
Sorry.
0.
and 0 at both the points. It's a particular point.
I'm not able to hear you properly. Can you repeat again?
Answer will be 0, ma'am.
No, no. 0 is, how can it be 0? It is not a PDF. It is a CDF.
But it is a continuous CDF.
No, it is.
No.
Can you plot the graph of it
You
first?
can plot from the CDF, you know.
Yeah. First thing you do is plot the graph.
It's 0.25, 0.5.
We will come to it. So first plot the CDF function. Like how will you plot it?
And can I put the answers after comma?
Yes, you can put it.
Yeah, okay.
Is it done?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
0.25, 0.5, 0.25. Okay.
No, 0.25, 0.25 will be the answer, right?
Can you please
Yeah.
question? Can you?
So there are many different answers I could see here. Yeah. So can somebody explain why, what is probability x equals to 0? First of all, whether it is a continuous CDF or discrete.
It's a discrete CDF.
Why is it discrete?
There is a jump at 0, right?
Okay, so it has a jump at 0, it has a jump at 2, it has a
Yes.
jump at 4, right?
Yes.
So it has a so this CDF is for the discrete random variable. And what should be the value for probability x equals to 0?
0.25.
0.25. And what should be the value for x equal to 2?
0.25.
Again 0.25, because at 2, as you can see, it is 1 by 4, sorry, 1 by 2, and the difference is just 0.25. Between two steps, you have the difference of 0.25. So again, probability x equal to 2 is 0.25. Yeah, because there are jumps here. So the answer for both of the questions are 0.25 and 0.25.
And, at 2 it is clear that it will be 0.25, but at 0
Okay,
it
so
is
for
given
x
x
for
lies
x less than 0, it is 0, right? And for x equal
yes,
to
that
0,
is
it
clear.
is 1 by 2. So sorry, here it is 1 by 4. I had told you have to interchange 1 by 4 to 1 by 2.
Means the
Like
question
the question
typing
is
error is
wrong
there.
here. There is an error here because the CDF
Okay.
should be increasing. Correct. So in the first case, it is 1 by 4. Second case, it is 1 by 2. I assume most of the people did wrong because of the wrong CDF here. So probability x equal to 0 should be 0.25. That is 1 by 4.
Let me calculate the PMF for this, ma'am.
Ma'am.
This is a discrete, then we will calculate PMF.
Yes. So what do you do for PMF? For you will have to find probability x equal to 0. What is the probability for x equal to 2? And what is the probability
Yes,
for
ma'am.
x equal to 4?
4,
So
yeah.
for x equal to 0, you have already found out. X equal
Yes,
to 2,
ma'am.
you have already found out. For x equal to 4 also, you can find out that. So what will be x equal to 4? What is the probability x equal to
1 by 2. Yeah.
1 by 2. So
0.5,
0.5.
ma'am.
0.5.
Yeah. Yes, ma'am.
So
Yes.
from here, you can find the PMF.
This is probability at point, right? At point, this is probability at x equal to 2. This is probability at x equal to 2, right?
Yes.
And then if we say at x equal to 2, what is probability? It will be 1 by 2 only. Sorry,
Sorry,
1 by 4 only, right?
What is the
At
probability?
x equal to 3. At
X equal to 3.
So then it will be half only, right? If I draw the graph, then it is flat between 2 and 4, right? It is a flat structure between 2 and 4.
Yeah, it has a flat structure between 2 and 4. Yes.
Okay, so with, should I say probability 0 at x equal to 3, or should I say probability is 1 half at x
Change
equal
is
to
probability. Change is probability.
There is no change in probability. It is remaining
So
constant.
in between the probability is 0.
Okay.
Sorry.
Yeah.
Ma'am, is this a step function? Discrete.
This is a discrete random variable.
Okay.
CDF for a discrete random variable.
Mm-hmm.
Because when you plot the graph, we can see it has a jump, right? There is no continuous curve. It has a jump
If we
kind
calculate
structure.
probability at x equals to 0, it is coming as 1 by 4.
1 by 4, right?
Right. And if you want to calculate at x equals to 2, do we subtract 1 by 2 minus 1 by 4?
Yes. You have to subtract the whatever the difference in the jump.
Difference in the jump, right?
Yeah.
Okay.
Okay. We'll move to the next problem.
May I ask a question here?
Yeah.
In the earlier one, the CDF seems to be coming down. Is that a possibility? Because it
No,
went from
yeah,
0 to half.
That's what I told. Like you'll have to interchange 1 by 2 to 1 by 4.
Okay, okay.
Some
Sorry.
typing error here. Yeah.
Sorry.
Okay. So this problem is from the normal distribution. This question says the test scores of statistic portion in the qualified exam are normally distributed. The mean score is 46. So if the standard deviation is 15, find approximately how many % of scores are between 16 and 61. You have some of the values of the standard normal distribution values given here. You can use it to solve the problem.
Ma'am, meanwhile, I have one question. Can I ask, ma'am, please?
We can discuss it once it ends. This is the last problem. After that, we'll take the problem questions.
Okay.
We can discuss on week 4 also.
Sure.
Yes, ma'am. This is a question of normal distribution, right?
Yeah, normal distribution. It is written there, right? Normally distributed.
पानी छाता बारू
Is it done?
Yes, ma'am. It's done.
Yes, ma'am. Done.
So, yeah, can somebody explain how did you find the
Yes, ma'am.
solution? Yeah.
Yeah. First of all, I find out the value of Z. Z is x minus mu upon standard deviation.
Okay.
Then I put the no, sorry. First of all, I find the value of x from this. Z is equal to x minus mu upon standard deviation. And I got the value of x as 15Z plus 46.
15Z plus
46. Yes, ma'am. And I put the value of x between 6 and 61. And I got the value of Z between -2 to 1. Then the probability.
The values are given. Probabilities are given.
Yes.
All right. That's fine.
Okay. Thank you.
So, yeah, thank you. So here we had to find like how many % of scores are between 16 and 61. It is given to us that the test scores are normally distributed. We have to find what is the probability. So if we denote this random variable, let's say I am denoting my random variable x as the test scores of the statistic portion of the test scores of the students, then that x, what is the probability that that x lies between 16 to 61? This is what we have to find, where x is normally distributed. But we know that if we have a normal distribution, we know the PDF, we'll have to integrate it and we can solve it. But that process is very complicated. So we go to the CDF value, and the CDF value, we find it using the standardization. We do the standardization of the normal random variable, and those values are already given to us in the form of table. So we just take the values from there and we substitute. The same thing we have done here. We knew what is the mean of the random variable x, we knew what is the standard deviation, and we have to find what is the probability that your random variable x takes a value between 16 and 61. Since we cannot, the integration is going to be very complicated using the PDF of x. So what we do is we convert this random variable x into our standard normal distribution, standard normal random variable, that is capital Z. And that we can do using subtracting the random variable x by mean and dividing it by its standard deviation. Same thing we have done here. We have subtracted the numerator, the x, from by 46 and divided it by standard deviation, that is 15. Since we have subtracted what the mean and divided by standard deviation for x, we'll have to do it same in both the sides. So we'll do 16 minus 46 divided by 15 and 61 minus 46 divided by 15. Once we do that, we will get this probability x less than lying between 16 to 61 as same as probability that your standard normal random variable z that lies between -2 to 1. So once we do it, we will get, using the properties of CDF, this is going to be fz of 1 minus fz of -2. Now this fz of -1 value is given to us. Fz of -2 is also given to us. We'll just subtract it and we will get some 0.81. It means some 81.8% of the scores are lying between 16 to 61.
The values of
confusion.
f of z1 is given, but if we want to find, so we use the CDF formula of normal distribution now.
I didn't get your question. Can you repeat?
Actually, ma'am, here fz of 1 is given and f of z -2 is also given. If we want to, if it's not given, so how we find this value?
So yeah, let's say x is some random variable and you have to find the probability. X is a continuous random variable and you have to find the probability between 16 to 61. And let's say you know the PDF. So what do you do in that case? The
PDF is given.
PDF is given.
Integration.
We'll integrate the PDF from 16 to 61.
But here is, ma'am, normal distribution. I
so
think
what? Yeah. So what
we have
is
a
the
formula
PDF?
of CDF. A formula of CDF.
Not the formula of CDF. We have the formula for PDF.
Yeah,
What is the PDF?
1 upon root 2 pi e to power minus z.
1 upon, yeah.
power
So
square by
PDF
2.
is 1 upon sigma under root 2 pi e to the power minus 1 upon 2 x minus mu whole square. Correct? Now, if you integrate that, like, is it easy to integrate?
No.
No, ma'am. It's tough.
So it's very complicated.
Yeah.
Like, you can integrate it, but it's going to be very complicated. You cannot always do such lengthy calculation. So what we have here is, like, we have already the tables where the CDF values are given for the normal distribution. That also CDF of standard normal distribution. Correct?
Okay, ma'am, I got this point.
Yeah. So that is why we are converting it to the Z form and directly using those values from the table to solve the problem. Is it clear to everybody?
Ma'am, one confusion.
Yeah. Can you tell
Ma'am,
me?
here you have taken this this equal to which the probability that 16 minus 46 by 15. This is equal to probability that minus 2 less than Z less than 1.
Right.
So
This
is
step
it,
is clear.
this first two
First two steps are clear.
No, first
No?
two steps, ma'am.
Yeah. So 16 to 61, right? So what I had said is you will have to X is a normal random variable. So you will have to convert this standard, this normal random variable to standard normal random variable that is given by capital Z. And we do it by subtracting the mean from the random variable X and dividing it by its standard deviation. So the mean is given as 46 and standard deviation is given as 15. So if you subtract the mean from the random variable X, you will get X minus 46. And if you divide by the standard deviation, you will get X minus 46 divided by 15, right? So this is going to be your Z.
Okay.
Okay. So if you have subtracted the mean and divided the standard deviation, the same thing you will have to do on the other two sides.
Okay. Same thing. Right.
Same thing you will do. General simple maths. So 16 minus 46 you will do and you will divide by 15. Same thing you will do 16 minus 46 and you divide by 15. Right. So this X minus 46 by 15, this become the standard normal random variable Z.
Okay.
And the left hand part, it becomes minus 2 and the right hand side becomes 1. So this probability that your random variable X that lies between 16 to 61, this becomes probability that your standard normal random variable Z lies between minus 2 to 1. Correct?
Okay.
Now, using the properties of CDF, correct? This Z is also a random variable, right? So using the properties of CDF, if what do we know? Like, let's say X is some random variable. If I have to write this probabilities X lies between 16 to 61 in the form of CDF, how will you write it? What is the property
F
of
of
CDF?
61 minus
F of 61 minus F of 16, correct? Same thing we will have to do with Z here because Z is also a random variable. Now this probability that your Z lies between minus 2 to 1, it will become Fz of 1 minus Fz of minus 2. Correct? And those values,
Yeah, and because you have given in the question it was given as CDF, so we have to use that property CDF and try to calculate it, right?
Yeah. The values are already given to you. You can use it to solve the problem.
Okay. If in PDF also, this is also, I mean, if instead of CDF, if it was PDF, then we have to do that integration and.
Yeah, but the integration is complicated. That's what I was trying to say. Integration is very complicated. So we already have a table where you can get the CDF values for the standard normal random variable. That is why we convert it to Z.
So the table, due to the table, we are given the values. So
instead of table, we have given you the values.
Okay.
To simplify our job.
What?
I said him to simplify our job.
Yeah, yes. This simplified the job. Yeah.
Okay. Okay. Thank you.
Okay. Yeah. Any other doubt in this? No? Okay. So that's all we had for the session. Rest I can take any problem if you have. So somebody had asked to
Ma'am, can I ask a
explain that.
question? Hello?
Yeah, let's first stop this. I'll come back to it.
Yeah, this particular question is about standardizing the normal the variable is independent of
I'm
the
not able to hear you properly. Just give
There
me a
was so
minute.
much noise.
Yeah, please mute yourself.
He is outside.
Ma'am, I have one small doubt about the normal distribution.
Okay.
Okay, so the thing is about in the normal distribution, like the last question, the values were given. What if the values aren't given? Do we need to integrate it? Like, will
Okay,
that?
let me just stop that periodic slide and then I will come back. Give me 2 minutes. Okay.
Hello.
Okay. Can you who was asking the normal distribution part?
Actually, most of the confusion about f of z of 1 or f of z, actually, it is given. So the confusion around f of z of 1 or f of those values given for f of z. I think CDF of 1, table something.
CDF of 1.
Ma'am, it's given now. Some CDF of 1 or CDF of -2, some values are given.
Those
So,
values were given, yeah.
Yeah. So all the confusion are around these values. I am clear that.
Yes, like what if the values aren't given? Do we need to integrate it in the exam?
No, the values will always be given to you because we don't expect you to integrate there.
Okay.
Yeah, values will always be given.
And I think these values are derived from CDF of normal distribution.
Sorry, CDF of?
Normal distribution. Normal distribution. अभी जो अब 0 to 1 normal distribution. So all those values.
I didn't get you.
Ma'am, the table, how the table is accumulated?
A table will not be given to you. The same way you had seen the values in the question, right? The same way it will be given in the exam if it comes.
Okay.
Okay. There won't be any table.
Ma'am?
Yeah.
Hello. Ma'am, any difference? I know there must be difference. What is the difference between Poisson and exponential distribution? I know one is discrete distribution, the other one is continuous distribution, right? But
Yeah.
both of them are having common parameter that is called lambda, right? So
Yeah.
in case of Poisson, lambda means some sort of average value.
Yes.
So what does lambda mean here?
Okay, here also it means the average value, but the exponential distribution gives you the inter-arrival time. Like in Poisson distribution, we generally talk about like
Average number
how
of people
many,
coming, yes.
Yeah, like
in a particular interval of time.
We divide the time interval into some fixed yeah. Correct. Like we have some fixed interval of time, and in each interval of time we assume the arrival rate is constant,
right?
And what we do in exponential is it is inter-arrival time. So like for how long a battery is going to last, something like that.
Could you share some more examples? It is not very clarity.
Yeah, wait. Okay. Did you check the practice book by any chance for
practice book? I think that is dedicated to week 0, ma'am, right?
Yeah. So yeah,
Hmm.
week 0.
So, ma'am, in that we can get all the distributions and all the explanation.
Sorry?
We can, in that book, we can get all the distributions and everything which was a part of
Okay,
week 0.
so yeah, that is definitely for week 0. We are also going to release for different week 4 onwards. Week 1, 2, 3 is not, we'll release it later, but week 4 onwards we will release it. So hopefully by today or tomorrow.
Given,
Sorry?
right?
What?
Short notes are given for each week.
And short notes are given. I mean, they explain
Okay,
notes.
full book. Okay,
Yeah,
full
yeah.
notes.
For each week, we'll give you.
That will be a great help.
Yeah.
Excuse me, ma'am. Is it okay to ask a question from week 2?
Week 2. Okay.
Yeah. The gradal assignment had a question number 8. Basically, I got it wrong, but I was not able to figure out what exactly needs to be done.
Okay. Did you check the solution?
The solution is already there.
Yeah, solution is already there.
Yes, solution is already there.
Oh, okay. Thank you.
Ma'am, are we going to discuss that
ma'am, I have
question, ma'am?
also doubt.
Poisson and exponential.
Poisson and exponential.
Excuse me, ma'am. I have one doubt in activity question.
Sorry to interrupt, but where exactly
Wait.
the solution itself? Because I know that
you can go to supplementary content.
Supplementary content.
Yes, yes.
Are you going to take the activity question?
Wait, I will take with line. Okay. Okay. So one was integration. Poisson
and exponential.
Right. What else? What activity question? Tell me the
I have a doubt.
question.
4.6 question number 1.
4.6.
Question number 1.
Okay.
I know the formula, but I'm getting the wrong answer. So explain.
Anything else?
Yes, ma'am. How to find the support of
Sorry?
in support.
I had a question.
In support of PDF.
Support of a PDF, okay. Support of a random variable, basically.
Yeah, sorry, random variable.
Anything else? Any specific doubt from week 4?
I have a doubt in activity. 4.5 fifth question, ma'am. Can you help me out in that, please?
AQ 4.5, question number 5.
Yes, ma'am.
Ma'am,
Okay.
I have a doubt in last meeting.
Sorry, can you repeat?
I had a doubt from graded assignment team. Asked me to ask at the end of the
Graded assignment 2. Did you check the solution?
not graded in 2, ma'am, 4.
Graded assignment 4, okay. Okay, the
Today
theory
is
part
the
we
deadline.
can
Tomorrow is
see.
the deadline.
tomorrow's the deadline, right?
So
Can you tell me which question number?
it is the 8th one, ma'am.
Question number 8. Okay.
You can share it from your.
Okay. Who had asked the integration part?
That was Aditya.
Aditya, okay. I don't think
He
he's
is
there.
left. Is left.
Yeah,
I
left.
think. Yeah.
Okay.
Ma'am.
I did 4.
Oh, okay.
Created for question number 8. Something very similar to this we have just discussed.
Yes, ma'am.
Yeah. So I think it should be clear now because we have just discussed this one. Okay, 4.5, question number 5. What is the doubt there?
CX is there, no ma'am?
Yeah.
So can you explain me how to go about it, please?
Okay. So your fx is defined as.
One second.
Now, can you please share the question?
I will write it here. So 0.1 cx 0.3. 0.1 cx 0.3, 0 otherwise. This is for x lying between 0 to 1. 1 to 2, 2, 3, 2 to 3. 1 to 2, 2 to 3. Otherwise, it is 0. We have to find probability that x lies between 2.5 to 1.
Yes, ma'am.
Yeah, we said there that okay. So we'll have to integrate it from 1 to 2.5 fx, right?
Yeah.
Can you mute? Yeah. So between 0 to 1, sorry, between 1 to 2, it is defined as cx.
Yes, ma'am.
So you have cx
Yeah.
dx from 1 to 2.
Okay, ma'am.
Then from 2 to 2.5, right?
It's 0.3.
It is
0.3.
0.3 dx.
Okay.
But we don't know what this is. So how will you find c?
Yes, ma'am. That is my question. Ma'am, can we add all those so that the sum of the probabilities is equal to 1? Can we do that, ma'am?
Okay,
That
so
is also not possible.
Is this a continuous random variable or a discrete random variable? What is
I don't know that CX, ma'am. I'm not able to identify.
This is PDF. This is PDF.
Without plotting, how we will understand? That is
Sorry?
It is a constant, so you can take it out, and it will be x square by 2, the integration.
But what is the C?
Yeah, that
if you
is-
have to find the probability, you have to find C.
Yes, ma'am. That is the doubt I'm having.
If it's
Yeah.
a PDF, if it's a PDF, then random variable is continuous, right?
Hmm.
And
Yeah.
as you was rightly suggesting that we will integrate all the components, and we'll sum it to 1, right?
Yes.
And if we solve it, the value of C will come 0.4.
Yes, right. So we know that this is a PDF. Okay, it is given to you that this is a PDF. And for any PDF to a valid PDF, if you integrate it from -infinity to infinity, it should come out to be 1. If now here it lies from basically 0 to 3, because from 0 to from minus infinity, from -infinity to 0, can you mute yourself?
Someone is talking.
Okay, so from -infinity to 0, this is defined as 0 dx. From 0 to 1, 0 to 1, it is defined as 0.1 dx. From 1 to 2, it is defined as cx dx. And from 2 to 3, it is defined as 0.3 dx. And from 3 to infinity, it is 0 dx. And this all should sum up to 1.
Yes.
So once you do this, you will find the value of C. And as I said, that C will come out to be 0.4. Now, once you find the value of 0.4, you can easily find this probability.
Okay, ma'am. Understood. Thank you, ma'am.
So whenever the a PDF is given to you, and you have to find such constant so that it becomes a valid PDF. Like, always remember this. Like, you'll have to integrate over the whole range and sum it over to 1.
And do we have to do this for all the values of range? I mean, all the intervals?
Yeah, you will have to do for all the intervals.
Or if it is given here between 1 to 2.5, you can do it for that short interval.
Sorry,
or
1
do
to?
we have to? It's given here x is
All the
between 1 and
intervals.
2.5.
You have to do all the intervals. Not get
You
constant
have to
values.
find the value of C, right? You have to find the value of C. So this you will find only if you integrate over the whole range. I mean, this property that the integral from -infinity to infinity should be 1. So it is for the whole range, not for a particular value. So in this problem, the range is mostly from 0 to 3. Other places it's taking the value 0. So you will have to integrate each function that is defined here over the interval. You cannot just integrate from 1 to 2.5 and can say this is my C.
Okay.
Ma'am, C will be 0.4 or 0.6?
I'm not sure. Like, somebody just told C is coming to be
0.4. Just a second. Let me check. 0.4. I'm sure 0.4. Again, let me check.
Yeah, I didn't calculate this. So this question is AQ 4.5, question number 5.
0.4, ma'am. No, I'm sure. I checked it. 0.4, ma'am.
0.4 only.
Yes,
okay? Yeah.
So constant integration will come as x, right?
Sorry?
Constant times x. For constant, the integration will be constant times x.
Constant time x. So this constant term will go out and you will have x dx. 1 to 2. So what is the integration of x dx?
Sorry, if 0.1 goes out, then it will be 1, right? Not x.
Sorry? You have this, right?
Okay,
right? What is integration of x dx?
Square by 2.
Square by 2.
X square by 2, yeah. So you just solve it, like put the range, you will get your answer. The same thing you will have to do it here. So it is going to be plus 0.3x, where x lies between 2 to 2.5.
Madam, I have a question. If we are past this.
Okay.
On the same one, actually, not a different question.
Okay.
When you actually put the limits, -infinity to 0, 0 to 1, 1 to 2, 2 to 3, 3 to infinity.
So much noise is coming.
Okay.
Yeah.
When you're looking at the limits that are set for each of these things, there is a greater than or equal, less than or equal to, or rather greater than or equal to and less than separate.
Yeah.
If the
Okay.
inequalities are changed for, let's say, the second one, instead of saying x is greater than or equal to 1, x is less than 2. If I make it as x is less than or equal to 2, will it change my
Here,
integrals? Will it change my, yeah,
you are saying if I make this
x greater than or equal to, yeah, and less than or equal to 2. Yeah. Will
this,
this change my integration?
no, this is a continuous random variable we're talking about. The PDF
Okay.
is given to you. It means this is for a continuous random variable. And you know that for a continuous random variable at any point, the probability is 0. So we talk about density there.
Okay.
So we talk about over an interval, like epsilon interval.
So the inequalities do not matter.
Inequality doesn't matter. So whether you find probability A less than equal to X is less than equal to B, this will be same as probability that you find A less than X is less than equal to B. This is going to be same as probability that X is less than A less than B. And this is same as probability that X lies between A to B.
Okay.
Yeah.
Okay.
So
But this is
For a continuous random variable.
Okay.
For inequalities, these doesn't matter. I mean, the probability is not affected if the inequalities are present or not.
No.
For a continuous. If it was discrete, then we have to, I mean.
Yeah, then you'll have to take care of it.
Next question. I'm asking for the question 4 point, I mean, GA determinant 4.8.
Sorry, 4.8.
I mean, question 8 question in GA.
Graded assignment question number 8. This has already been discussed in the Solve with Us, right? Just now I had discussed something like this.
Given as,
I mean, in the problem number 6, I guess.
Yes, ma'am. Yes.
Yeah, I have just discussed. Just go back and see once.
Some transformation. It's not similar to that actually. So
no, it is similar to whatever I have discussed.
Here, it's given as x is for 0 is for x is
the function is different. The function is different that is defined, but the concept is same.
So basically, you will have to do the sum of the parts of the integral. That's all right. It's because it's given from 0 to 1. Split into 0 to 1, 1 to 2, and 1 to 2, and 2 and above. So
I will suggest you can just go back to the session once and just say it. It's the same thing.
Oh, here the third one is it? The point number 3 you're discussing the same thing, is it?
GA question number 8, right?
Yes, ma'am. But you said you had already covered that here. Similar one. Which one was that in this list? Actually, third one, is it? 4.6 question.
4.6 question number 5.
Okay. That is the one which is similar to one, is it?
No. You have asked GA 4 question number 8. This is similar to question number 6. Solve with us, which is just now we have discussed.
Question
recording,
6.
you can see the recording is available for the session.
It is there on YouTube. You just go to the YouTube link and you can check this just now. Okay.
The test one which we solved just now.
Sorry.
Strange, very strange.
Which we solved just now.
This GA4 question number 8. Something very similar to we have solved in Solve with Us.
आणि efficiencyचं हे तर काहीच डिटेल्स नाही ना देता काही.
Okay, so what is support of X?
The values for X, the probability is not 0.
Yes. So if you have any random variable X, so the support of X, this is given by like all those X, okay, for which the probability, so for which your fx of X is greater than 0. This is what is defined as support of X.
Yes.
Okay.
Can you
So,
take an example?
okay, so let's say I have a PDF function fx of x that is, let's say it is 1 for x lying between 0 to 1. Otherwise, it is 0. Okay. Now, what should be the support of x here?
1 included.
1.
1 included.
This is
0 to 1.
0 to 1.
Included.
Both
Included, both included,
Yes, yes.
right? But if in place of this, if I would have written, let's say 0, x1, then support would have been 0 to 1, open interval 1.
Okay.
So you should just keep this in mind. Like you have to take all those x that the random variable is taking, such that the probability density function fx of x is greater than 0.
Okay, for all the values of x, we can.
Ma'am, doesn't it bring a doubt? Like,
Just a second.
In case,
Sorry?
sorry. Yeah, continue.
Just a second.
Okay.
Ma'am, my doubt is if instead of 1, if it was given some unknown variable, like some 2 x, k times x, and the limit was given to us. Sorry, k times x.
K times
and,
x.
Instead of 1, it was k times x, and the limit was between 0 and 1.
Okay.
Then first we have to
You'll have to find the value of k.
Okay, and we have to, means like what you said just now, to calculate value of any
Okay,
unknown.
even if you, let's say if it is 0, right? Let's say if it is 0. So even if it is just k of x, and if you are saying it is a density function, it can never be negative. It should always be positive, right? And it cannot be 0 also, because let's say this is our density PDF given to us, right? Now we know that your fx of x should be
greater than or
equal to 0. Huh?
Yeah.
So this is always going to be a positive number, right?
K.
Okay.
For any positive
because
number.
if you integrate it, like if you integrate it, you are not going to get a negative value here.
Okay.
Yeah.
Its integration
So,
will be kx square by 2.
Kx square by 2, and you take the limit, it will be.
Also, ma'am, x lies between 0 and 1.
X
That
lies
is,
between 0 to 1.
That is
right.
positive. So k will have to be positive, ma'am.
K will have to be positive.
Right.
Right.
K
Yeah.
is greater than
Otherwise, it will go to negative. Yeah.
Yeah. Yes.
Ma'am?
Yeah. So, ma'am, this support is just the x values which are getting the function to positive. This is called mainly the support. Means all the values of x.
Yeah,
f
this
of
is.
x is
Yeah, this is
positive.
Yeah, f of x is positive. This is our support.
Ma'am?
Thank you.
Okay.
Hello, ma'am?
Yeah.
I think 0 and 1 should not be included because it's a continuous random variable. So probability at a particular point is always 0, right? So I think
probability at a particular point is always
0. So it will be open bracket, ma'am. And as you rightly discussed just now that in continuous random variable this equality sign doesn't make sense, right? Even we can write it as 0 less than equal to less than x less than 1.
For random variable, continuous random variable, open and close, it's the same thing.
Correct. So I think 0, 1 is the answer, but it's open bracket.
Excuse me, ma'am.
Open interval, not closed interval.
Okay.
Yeah, it's open interval, ma'am.
Ma'am, I'm asking. I think there will be not any case where the fx of x will be less than 0. Is there any case, ma'am?
No, fx of x is not going to be less than 0.
In some interval, you are telling that the support of x is x where fx plus x is greater than 0.
Fx of x is greater than 0, right?
So there will be no any case where fx of x will be less than 0.
No.
So the support we can always find out the support.
Or even equal to 0, is it?
Oh, it can be equal to 0. Yeah.
Which one?
Fx of x
Yeah, fx of x can be equal
can
to
be
0.
equal to 0. But
Yes.
it will
So
not
Zero
be
greater
less
than
than
zero.
0 because it will not be the valid PDF.
yes, it cannot be less than 0.
Okay, ma'am. And the
It's got to
support
be
is
a square
only
bracket.
when
Closed
fx of
bracket.
x is greater than 0. Okay. Okay, fine.
Yeah.
Okay, thank you.
And there was another discussion going on. It need not be a
Support.
closed bracket.
Yes,
Yeah.
it should be
Wait.
open interval, not a
Right or no?
So support of x, if you take 0, if you take 0 also, it is defined as it is going to take the value 1. I mean, the probability is going to be 1.
But as per definition of continuous random variable,
Yeah.
probability
Okay.
of a particular point is always 0. I think this kind of question is there in one of the activity question also, ma'am. And
Activity
the
question, it is there. Okay.
Yes, sir.
Which
So the
activity
answer-
question?
that I have to figure out, ma'am. So the answer is open interval only, not closed interval.
Okay, let me check. I think maybe 4.5.
It is both same. It is since it is continuous, so open interval and closed interval are both same. If you write 0 less than x less than 1, that is same as 0 less than equal to x less than
On
equal
that
to 1.
basis, on that basis only we are
Okay,
saying
okay.
that
It
the answer
is.
If you are
It is
answer-
there in activity 4.5, question number 6.
Yeah, so it's open interval, ma'am, not closed interval. And that is the explanation, ma'am.
When x takes the value 0, the probability becomes 0, right?
Yeah, right.
So it cannot be part of the support.
It cannot be part of the support, correct. Okay, yeah, right.
So it's open interval, ma'am, right?
It's open interval 0, 1 here.
Okay. Thank you, ma'am. Thanks for the clarification.
Sorry, ma'am. Ma'am, how we decide of
read?
this open and close interval, ma'am? As you said that if it was 0 included and 1 not included, then
Yeah, here somewhere I've written. Yeah, if you had to find the probabilities, so all this gives the same values. Okay, but in case of continuous random variable at any particular point, like probability, if x is continuous random variable, and if you have to find the probability at a particular point, it will give you the value 0. It gives you the value 0, right?
Okay.
So here in this case, like even if you add like 0 or 1, like at a particular point, fx of 0, this will give you the value at a particular point, it will be 0.
Yeah.
So this is why we are saying that the support is 0 to 1.
But open interval.
Open interval, yeah.
Open interval 0 to 1.
Because
for the support part.
Yeah, because the reason is because we are taking the values between 0 and 1. I mean, sorry, 0 and 1 we are taking,
We are
right?
taking the values of x for which fx of x is greater than 0. But
I have a question.
At a one point x is
yeah.
equal to 0, you will get
Ma'am,
probability
in
0.
a given function as a PDF,
Yeah.
the value of range is greater than 1.
Value of the range.
As we look here, the value 1 is given, and the range is x 0 to 1. So is there any other part where the value the range is like 1 to 2 or 2 to 4 or something like that?
Yeah, it can be any range, no? I mean.
Yeah, ma'am. Actually, we did a question in pair. So there's a question where probability x is greater than 4. We took range 1 by 4 to 1.
Can you repeat?
Actually, ma'am, here I think we did a question where we find a conditional probability. So where we need to find a probability of x greater than 1 by 4.
Okay, probability x greater than 1 by 4.
Yeah, the part
given
of question
that
is,
x is less than 1 by 2.
Yeah. So, ma'am,
Something
here
like
we need to find x probability of x greater than 1 by 4 now. So we took limit to 1 by 4 to 1.
We take limit from?
We take limit from 1 by 4 to 1, I think.
In the numerator, we take
numerator.
1 by 4 to 1 by 2. Because
no, ma'am, denominator, I think.
Okay, denominator, it will be x less than 1 by 2. So 0 to 1 by 2. It should be 0 to 1 by 2, right? Because x is less than 1 by 2.
Okay.
So
no,
it
ma'am,
is going to be.
Actually, in that question, x is greater than 1 by 4.
Okay, x is. Here
no,
also it is x is greater than 1 by 4.
No, ma'am, the other one, the condition, x is greater than 1 by 2. Where is x is less than 1 by 2? Yeah. So this part is in.
So it is given that x is greater than 1 by 2.
Yeah.
Okay. What is the probability that x is greater than 1 by 4? So it is going to be that x lies between 1 by 2 to 1.
Okay.
Right.
2 to 1, ma'am.
Yeah, 1 by 2 to 1.
Okay.
Next one in the list, ma'am.
4.6, question number 1.
My doubt got cleared, ma'am. If you want to skip that, you can skip.
No, we'll discuss it.
Okay.
It was more theoretical, so I have left it for some time. Okay, 4.6, question number 1.
Can I tell where I was going wrong?
4.6, question number 1.
Yeah.
Okay, yeah. So x is, I'll just write it here. AQ 4.6, question number 1. X is uniform in 4,6. What is we have to find?
We have to find the probability x lies between 1 to 5. Open interval.
X lies between 1 to 5.
Yes. What I was doing previously, ma'am, I was taking the interval from 1 to 5. Ma'am, 2 to 4, not 2 to 6, not 4 to 6.
Okay, 2 to 6.
Yes, ma'am. What I was doing, I was taking the probability from 1 to 5. So I was getting a wrong answer as 1. I forget that from 1 to 2, the probability will be 0. We have to take from 2 to 5. Yeah, that was what I was doing wrong.
Okay, so it is 2 to 5.
Yeah. So I got it right now. I solved it. Okay.
So this is also done. Poisson and exponential.
It's not really understandable.
Sorry. Is anyone speaking?
The question that was brought up now.
I cannot hear. Can you speak loudly a little?
We have, the question that we just now discussed, we can understand that.
The question we just discussed.
Yes, can you explain that?
Okay.
4.61.
4.6, question number 1.
Just now, I was pointing out the question which
Okay, so this is what we had discussed just now. So this was a problem. It was given to us that x was uniform in 2 to 6. So what is the probability that your random variable x lies between 1 to 5? So if you have to find this, you basically have to do that integral 1 to 5 fx of dx, right? And since this is uniform in 2 to 6, your fx is defined as 1 by 4. So you have to do integral 1 by 5, 1 by 4 dx. But you see here that from 1 to 2, this probability is going to be 0. Is this clear that why from 1 to 2 it is 0?
Yes, ma'am, that part is clear.
That part is clear. So from 1 to 2 it is a 0. Then you will take from 2 to 5 1 by 4 dx and you will integrate this. What is the problem in this question?
How this 1 by 4 you got from?
How did we get 1 by 4? So it is given that x is uniform in 2 to 6. So just see the figure here. X is uniform in 2 to 6. So if you have any random variable that is uniform in an interval a to b, then its distribution is given by 1 upon b minus a for x lying between a to b. Otherwise it is 0. So here it was uniform in 2 to 6. So the effects will be defined as 1 upon 6 minus 2. So 1 upon 6 minus 2 becomes 1 by 4.
So the uniform between a and b, then 1 by b minus b for the whole interval, right? No, if it's uniform between a and b.
If it is?
If a function is uniform between a and b, this is applicable in that
Yeah.
case, right?
Yeah, yeah.
1
If
by
of,
b minus
yes, yes.
Pardon me, ma'am. Am I audible? Hello?
Yeah, you're
Hello?
audible.
Yeah, ma'am. I didn't get this. Shouldn't it be 1 by 5? Like we have got like how many values? From 2 to 6, 2, 3, 4, 5, 6.
It is not discrete. This is continuous.
Oh, sorry, my bad.
Yeah, this is continuous. Okay. So coming back to the exponential part. So in geometric distribution, in discrete distribution, you have the geometric random variable. So, sorry.
Yes,
Yeah.
You are answering my question, ma'am, now?
Yes.
Yes, Poisson and exponential. I had asked that question. That
Yes.
what is the difference with Poisson and yes.
So exponential is equivalent to like geometric random variable. So in discrete case, we have the geometric random variable, and there we talk about the number of trials until you get the first success, right?
Correct.
So there we talk about the first success. But in case of exponential, we talk about a continuous time until which something has happened, the first phone call that we got, or the first radioactive until a radioactive particle decays. So the time until which the first event occurs. So such kind of situation we model using exponential. So geometric, the way you see geometric in the discrete world, you will have to see this exponential the same way in the continuous world.
Okay, so it has no relation with Poisson. Like I was just wondering that both of them are having parameter common, that lambda, both of them are having lambda parameter, lambda-ish parameters, right?
Yeah.
So that was driving force for me to ask this question.
So in Poisson, so there is a relation between exponential and Poisson. So this lecture will not discuss it. So okay, just see it here. So for Poisson lambda, what is the mean that you give?
Lambda, ma'am.
Lambda. And what is the expectation for exponential distribution?
Expectation for exponential distribution.
Yeah. What is the expectation of exponential distribution?
1 by lambda, but I only found that out
I
from
think
the.
I think we have not covered so far on that.
Yeah, it's not covered, but I think it's in the practice
yeah.
assignment.
Yeah, that is
it's
coming.
But it's not covered.
No, it is coming in week 5, ma'am. Week 5 or week 6 it is coming.
Is it given in week 4?
No, it is not.
It is in the practice assignment.
Okay.
In the answer to the practice assignment, only there.
Okay. So this part is not covered in week 4. Okay. Okay.
But I think it should be fine. This should be fine, I guess.
Subsequent weeks.
Sorry.
Someone was
Okay.
saying something. Someone was saying something. So
No,
Yeah,
I was
yeah,
I
continue.
was just saying that I only looking at the expectation of the exponential should be fine because 1 by lambda is just not that hard to memorize. So
yes, it's not
Yeah, so for the exponential distribution, your expectation is given by 1 by lambda, and the variance comes out to be 1 upon lambda square. And in case of Poisson, both
lambda.
both is
yeah.
lambda. Both are lambda.
Yes.
Ma'am, I think this was actually done in statistics 1.
Yes,
Really?
yes, it is done. That's one, correct.
And in stat 1, this such topics were never discussed in this kind of detail, man. There are only total 4 to 5 lectures. Week number 12 is talking about continuous random variable.
Okay.
Ma'am has just does everything at the surface level, and then she told you everything will be discussed in detail in advanced courses.
Okay. Right.
I don't think that functions and all these derivations were discussed in stats 1.
Okay, so how did you find stats one? Like as compared to stats two, is it you find it very easy, or do you find
Now it seems easy.
Okay.
Now it seems easy. Ma'am, so related to this, I have other questions. We can discuss this in subsequent weeks, ma'am.
Okay.
How these probability density functions are getting derived? Like for lambda, for lambda, for exponential functions, we have one type of PDF. For normal distribution, we have one type of PDF. So how these PDFs are getting derived, ma'am? Out of curiosity, I'm asking this question.
How these PDFs are getting derived? Okay,
Yes,
so this maybe it is we can discuss it in the, after the quiz gets over. I think.
Okay.
I
And
think
then
it will be interesting.
Okay, ma'am. And then the third component of my question is, ma'am, while studying normal distribution, I think somewhere I saw that professor in one of the slides is writing, when we are defining that normal distribution is defined as having two parameters, mu and sigma square, right?
Yeah.
So he is defining mu as a location parameter and sigma square as a scale parameter. So what do they mean, ma'am? What do they mean?
Okay, so mu is defined as
location parameter.
Location parameter, yeah. So this is scale parameter. Yeah. So what is mu?
Mu is mean expected value.
Mu is mean, and sigma is, this is standard deviation.
Standard deviation.
So basically, what does your mu give? I mean, where your most of the values are clustered.
Long-term average, yes.
So that is why we are saying this gives you the location, like where most of the values are clustered. And why sigma is called the scaling? Because like once the standard deviation decrease, like the spread of the graph decrease. So if you change, like if you scale your sigma, the distribution will vary, right? Like how do I say this? So you have normal with mean mu, variance sigma square. Okay, scaling part, I think I'm not very sure how to explain this.
So as increasing the magnitude of something, then we call it as scaling, right?
I like what I feel is like, because it gives the standard deviation is giving you the spread of the distribution. So yeah, so this may be one of the reason we call it scaling. Okay, this part also we can discuss.
Okay, so I will put all these questions in this course, ma'am. Please take a note.
Okay. I think you had posted one more question there. I will check there. Okay.
Ma'am? Hello?
Yeah.
Okay, yes. I will come back again.
Okay, sure. Anything else? So how is the quiz preparation going on? This week you have the quiz. Is it going fine, the quiz preparation?
Not yet started.
Not yet started? Okay.
Ma'am, what's the level of difficulty that question come in quiz 1?
Sorry, mock, yeah, almost the same level of difficulty. Even the portions that you see, portions are also going to be more or less same.
Ma'am, are normal distribution and exponential distribution also part of the syllabus?
It is
For
in
this
week 4, right? It is in week 4.
Yes,
Oh,
yes.
okay.
Yeah. So it is there.
So 18 questions will be there in the quiz 1.
18 questions will be there, yeah. Maybe less, a little less or more, but somewhere near.
Ma'am,
Yeah.
as we have been told to refer like Shiva Tharva book, right?
Shiva Atare, yeah.
Right. But the kind of derivation which a professor is explaining in a couple of videos, right? And then he leaves also some of the derivation, and then he gives us assignment that okay, take it as a homework and you do it on your own. So derivation part is missing in that book, man. It is not so extensive. So which book to refer?
Okay, derivation part, you can always check on internet also. It is there. Like most of the derivation, it will be.
There are so many discussions happening now. It is very tough to find out the correct answer. Unless I know
You can always go to
answer.
Math Stack Exchange. There you will find correct answers.
Or any good book, ma'am, for mathematical part of statistics, for mathematical statistics?
Mathematical statistics, Shivatraya is mostly mathematical statistics. You can also, Walpole also, I think we had suggested. Walpole also you can refer. And these parts, even in Sheldon Ross, these parts are there. The joint distribution, expectation, Markov-Shiver shapes.
Mathematical part also?
Yes. Ross also till week 3, week 4, you can find the content. And in the lecture, sir has given 2-3 references. I think you have gone through it. There are many references sir has given. So derivation part, I will suggest you go to internet and check a little better. Okay, anything else? Anyone?
Ma'am, is week 0 given equal weightage?
No,
One,
week
two,
0,
three, four.
No, week 0 is not a part of your quiz.
Also, there are so many distributions that we need to learn. When there are word problems, when we don't know what distribution it is and we need to understand from the question, it gets kind of confusing. So, any help with that?
Okay, so what kind of distribution you find difficult?
So, in last week's graded assignment, there was this question. It was a simple question, but I had to ponder over it for some time to understand this is geometric distribution. And then I figured it out. But that part that I can't understand.
You mean the light bulb question?
I think number of objects that are kept aside.
Yes, defects.
Yeah, that
number of defects.
Yeah.
Ma'am, in that question,
Huh?
what if if the defective bulb was not put aside? Would the answer have been any different?
Defective bulb was not kept aside. Let me
Then
check
it
the
wouldn't be a
question.
geometric distribution, I guess.
In that case also it will be geometric distribution. The question
What was
talks
the
about
question?
probability of getting the first defective product. So getting a first defective product is defined as a success for me.
Yeah, getting the first defective was defined as a success
for me. So that will be geometric distribution. I think so. I may be wrong.
No, but what I'm curious about is that particular line which said that the defective element has also was placed. I mean, Why mention
Okay, so
that separately?
why it is mentioned is because okay, the question says suppose 1800 products that are coming out of production line is defective. There are 100 products, we know 8 are defective. Okay, and you have to randomly pick the objects and keep aside till you find the first defective item. So let's say the objects are passing and the first item you choose, that only is defective, right? So even on the first trial, you got the first effective item.
Hello.
Wait.
In that case, if the defective item was not set aside, the value of x would be 0.
Yes, right.
So geometric distribution cannot have zeros.
No, okay, so geometric distribution can have 0, but if it happens, like if even in the lectures that said, like some people take the range from 0 to infinity. So what the difference it makes is if you try to calculate the expectation and variance for both the cases, like when you take the range of geometric from 1 to infinity and when you take the range from 0 to infinity. So expectation and variance are different in both the cases.
Okay.
Or maybe just the expectation alone is different, variance is same. I'm not very sure. You have to derive it and check. So there the difference come. I think expectation varies in both the cases, but variance remains the same.
Ma'am, just related to this discussion only. Say for example, I am rolling dice twice, right? And I am noting down some of the outcome, right?
Okay. Yeah.
So what is the distribution of this random variable? How to identify that? What is the distribution of this particular random?
How will you? Okay. So what is your experiment? Your experiment is
my experiment
you're tossing two.
Rolling a dice.
Okay, rolling two dice.
Two dice and noting down the sum of the outcome, right?
Okay.
So which distribution is this?
So how will you figure out? You're not saying anything about what you are interested in finding. Like you just said, you're writing down the sum of the numbers that you're getting.
Yes.
What it is that you're interested in? What do you want to find?
No, our discussion started that, say for example, some question is defined, right? And we have to identify the nature of the distribution, that how to identify the nature of the distribution, right?
Yes. So what the question you just asked, I don't know who had asked. So whatever you had asked, so there, what do you want to find? Like there is no much context to.
Okay. So you are saying that we have to take the help of or the some insight what is being asked. We have to take insight from that also, right?
Yes. So here you have just said two dice has been rolled and you are just writing down the sum. But what is it that you are interested in or to find?
So the question is that, say for example, I did this experiment for 1,000 number of times, and now I have to plot a graph, right? So I have to say that I have to say the nature of distribution. What will be the distribution of this random variable? Whether it will be following a normal distribution or will following binomial or uniform. So what should I say? Like say for example, when I'm throwing a die, then we say now that's a uniform distribution. We don't say much, but still we know that the nature of distribution is uniform distribution.
Okay. So there, we said like you have a die and you roll one die, and we know the probability with which each of the values will occur is 1/6. So it is uniform in 1/6. Now we have two dice and we are throwing it like rolling the two dice, and whatever the sum is coming, we are just writing it down.
Yes, we are writing it down. So which distribution will it follow?
You cannot say from here what distribution will it follow. You'll have to find the probabilities for each of the sum that you will get.
Okay.
And then maybe you can try to plot the graph and see if it gives a particular shape or something.
Okay. So just to summarize our discussion, it means we need some more information to find out the nature of the distribution.
Yeah.
Right?
Yeah.
Ma'am, may I say something here? Like, I think we should first figure out what we are trying to do.
Yeah, that is the main point. What you are trying to do.
Binomial or a normal distribution, like it depends on what we are trying to find out. Like 7 would have probably the most
if it's a sum of two numbers, that is.
The first is you should define your problem. Like, what is your
Exactly.
problem?
So
Once you define the problem, then
that's
on the
what,
basis of that.
that's what we are converging, that we need more information to figure it out. Right? Hello?
Yeah.
Yes.
I mean, I came across this like, expectation for a binomial kind of variable would be NP, right? But even if we take uniform distribution for a roll of a die, it will always be 3.5, no matter how many times you roll it, right?
Yeah, it is 3.5.
It is independent of n. So that's how, like, I think it's important what are you trying to define, the definition of the problem. But ma'am, coming back to like that light bulb thing, like I'm not still clear about that information about the defective part being kept aside thing. If you can kindly spare a minute on that.
Okay, defective item is we are keeping it aside. So in this case, the way we had defined it as the number of items that you're keeping aside. This is how you have defined the random variable x represent the number of products that are kept aside, right? So let's say if the first item you picked, right, and that is defective, so number of products that you're going to keep aside is going to be 0, correct?
Okay.
I'm not sharing my screen, right? Wait. So is this visible?
Yes.
Okay.
Visible.
So x is defined as number of items that you keep aside. Okay. Now we have 100 objects, out of which eight items are defective. Now let's say the first item you picked, and that came out to be defective. So if you keep it aside, okay. So if the first item is only defective, it means you're not keeping any items aside, right? It means 0. If you get the first defective in the second trial, it means the first item that you got was defective and you kept it aside. So it will take the value 1.
Okay.
Similarly, it will go from 0 to infinity. Not infinity actually, because you have just 100 items. So it starts from 0 here. And we know that we are interested in this model's geometric distribution, right?
Yeah, I get that it's a geometric distribution because now with the familiarity of such problems related to geometric distributions, only that way I can say that this could be a geometric distribution. But that, getting the defect on the first draw is what is like.
So number of items that you keep aside, like if you get the first defective on the first trial, you're not keeping any item aside. It means 0. That is why it starts from 0. So this is why we are saying that even assume that the first defective item is also kept aside. So whatever, if you are getting the defective item on the first trial, that you keep it aside.
Okay, so I believe then it's just to conform with our assumption that the range of a geometric random variable begins.
Yeah, we just wanted to make sure that
will become 1. Okay,
yeah,
okay.
Yes.
Got it now.
Got it. Okay.
Thank you.
We just wanted to make sure.
Yes, we got the success in first trial itself. Ma'am, can you share the screen again, ma'am?
Okay.
Then in geometric distribution itself, say for example, I am tossing a coin, and in third trial I am getting my success means head, right?
Third trial you're getting a success. Okay.
So yeah, so probability of getting a success in third trial will be 1 minus p to the power 2 into p. So it will come down to 1 by 8, right? 1
Yeah,
minus,
it is 1 by 2 to the power cube. Yeah.
so it will come down to 8. So now
1 by
ma'am,
8.
yes ma'am, now say for example, it means I have already tossed coin twice and I have not got head, right? Now I am going to toss the coin for the third time, right?
Okay.
So what should be my interpretation for the third toss? Whether I will be getting success in third toss is 1 by 8, or I will be getting head in third trial is half only, because all are independent events, right?
It is going to be one, like probability that you are going to get a head on the third trial is going to be 1 by 2.
1 by 2 only.
Because your coin is fair and all the trials are independent. If you toss,
what to infer, ma'am? What to infer from these two information? When my probability is going to be half only in every trial, right?
Yeah,
then what does this 1 by 8?
You have 3 trials. Okay.
Correct.
You have, like, you're tossing the coin 3 times, and in each of the trial, the probability that you get a head on each of the trial is going to be half.
Correct.
Right? Probability that you get a head on the first trial is half. Probability that you get the head on the second trial is half, and probability that you get the head on the third trial is also half. So if you are saying that till the first 2 trials we got tail, but on the third trial we got a head. So this probability, like if you're saying it comes out to be 1 by 8, so what you're trying to say is, like, what is the probability that you get a head on the third trial? The first head you get on the third trial.
Right.
First head on the third trial. That probability is 1 by 8.
This calculation part is clear, ma'am. I'm just thinking the practical application part.
Yeah,
of
practical
this.
application is like, what is the probability that your first head appears on the third trial?
I was just thinking that can we say that the chances are very rare that we will be getting continuous 3 tails. So the chances of getting head is high in third trial. Can we interpret like that?
Can you repeat?
Chances of getting three tails in a consecutive trial is very less. So chances of getting head is high in my third trial. Can we say like that?
Chances of getting the head on the fourth trial is high.
Yeah. Yes, can we say like that? Because can that be one of the interpretation?
Okay. Yeah, we can say that. So this will come out to be 1 by
16.
Okay, we can only say if we can find the probability.
Because this formula is the mathematical aspect of that, right? But what is the formula is the mathematical aspect of the calculation, right?
Formula, yes.
I will put the value, I will compute the value, and I will get the answer. But what is the practical application of that? Like probability of getting
for probability of getting the first success. Okay, probability that you get a success on the first trial.
That is half.
That is going to be half. Probability that you get a success on the second trial is 1 by 4. The success on the third trial is 1 by 8. So probabilities are decreasing, like chances are reducing. So probabilities are reducing, right? Like probability that you get in the first trial, you get the first success. The chances are high here. On the second trial, you get the first success. It is a little, It is lesser than what we had for the first trial.
Correct.
Um,
But if you think intuitively, so probability should increase, right? Because chances should increase getting first success. If I have not got head in fourth trial, now I can say that I can get head in fifth trial. I can get head in sixth trial. But while computing through formula, it is
but
continuous.
no, for each of the trial that you get a success is same. That is 1/2. Like for each of the trial, the probability is same only. It is not changing. It is 1/2.
So how geometric distribution will help me in taking a business decision, ma'am?
In taking the business decision, okay?
Say for example, I am doing some experiment in my research and R&D lab, right?
Okay.
So it is showing that probability of getting a success is decreasing as my number of experiments are increasing, right?
As the number of trials are
Correct.
increasing, the probability of getting your first success
is decreasing.
Yeah.
But in real life, we do a number of trials and then we get success, right? So it is misfitting somewhere.
Okay.
Can you repeat what you said just now? I mean, I didn't understand that part.
Yeah. Yeah, can you repeat the statement?
Yeah, I was just asking that what is the practical application of geometric distribution? Because here what we are seeing that probability of getting first success is decreasing as number of trials are increasing, right? So say for example in R&D we are doing some experiments. So can we say that probability of getting a success will decrease as number of experiments increase? But in real life things happen in reverse way. We get success, like pharma companies get success only after doing 100 of trials. So how to correlate, geometric distribution with real life application? That is only.
But that's different, right? There are lots of parameters that come into play after they do a lot of
Let us put all the variable constant. Okay, let us put all the variable constant.
If you put everything constant, then you probably get the same results.
I'm just trying to understand that what is the practical application of the geometric distribution in real life.
Okay, we can also can you also post this on Discord?
Sure, ma'am. Sure. Okay, ma'am. Thank you.
Okay, yeah. Okay. So we'll close the session here.
Yes, ma'am. Thank you.
Yeah. I hope you all are going through the mock. Also, some practice problem has been uploaded in the form of peer text slides. I will suggest please go through that also. Okay, so thank you all. We'll meet again on Thursday.
Thank you, ma'am.
Yeah, thank you.